Hello everyone, my name is Harivansh Dugne and today we are going to discuss about the machine learning algorithms. Let's start. Machine learning is a subset of artificial intelligence that enables systems to learn from data and improve their performance without being explicitly programmed. Instead of following fixed rules, machines use algorithms to identify patterns in historical data and then use those patterns to make predictions on new and unseen data. The concept was introduced by Arthur Samuel in 1959, who defined it as the ability of computers to learn without explicit programming. The key components of machine learning include data, which is the raw input, features, which are the important variables, models, which are the mathematical representations, training, where the model learns, evaluation, where performance is measured, and prediction, where the model is used in real scenarios. Today, machine learning is widely used in industries such as healthcare, finance, and technology for tasks like diagnosis, fraud detection, and recommendation systems. Now, types of machine learning. Machine learning can be broadly divided into three types: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the model is trained using labeled data, meaning each input has a corresponding output, and the goal is to learn a mapping between them. This is commonly used for classification and regression tasks. In supervised learning, the data does not have predefined labels, and the model tries to discover hidden patterns or structures, such as grouping similar data points. Reinforcement learning, on the other hand, involves an agent interacting with an environment and learning through rewards and penalties. The agent improves its performance over time by maximizing the total reward. Each type serves different purposes depending on the problem being solved. Now, we discuss about supervised learning algorithms. Supervised learning algorithms are designed to learn relationships between input features and known outputs. One of the simplest algorithms is linear regression, which predicts continuous values by assuming a linear relationship between variables and minimizing the error between predicted and actual values. Logistic regression is used for classification problems, especially binary outcomes, where it predicts probabilities using a sigmoid function. Another popular algorithm is the decision tree, which uses a tree-like structure to split data based on conditions, making it easy to interpret. These algorithms are widely used in real-world applications such as predicting salaries, detecting spam emails, and making loan approval decisions. Now let's come to our next unsupervised learning algorithms. Unsupervised learning algorithms work with unlabeled data and aim to identify patterns or groupings within the data. One common algorithm is k-means clustering, which divides data into a predefined number of clusters by assigning points to the nearest centroid and updating those centroids iteratively. Another approach is hierarchical clustering, which builds a tree-like structure of clusters either by merging smaller clusters or splitting larger ones. These methods are useful in applications such as customer segmentation, where businesses group customers based on behavior. However, these algorithms can be sensitive to parameters and computationally expensive for large datasets. Reinforcement learning overview. Reinforcement learning is a type of machine learning where an agent learns by interacting with its environment and receiving feedback in the form of rewards or penalties. The goal is to develop a strategy known as a policy that maximizes cumulative rewards over time. The process involves rewards over time. The process involves concepts like states, actions, and rewards and is often modeled using Markov decision processes. The Bellman equation helps in determining the optimal strategy by evaluating future rewards. Popular algorithms in this domain include Q-learning, deep Q networks, policy gradient methods, and actor-critic models. Reinforcement learning is widely used in applications such as robotics, gaming, and self-driving cars. Popular algorithms explained. There are several advanced machine learning algorithms that improve performance and accuracy. Random forest is an ensemble method that combines multiple decision trees to reduce overfitting and improve predictions. Support vector machines work by finding the best boundary that separates different classes and can handle complex, high-dimensional data. K-nearest neighbors is a simple algorithm that classifies data points based on the majority class of their nearest neighbors. Naive Bayes is a probabilistic algorithm based on Bayes theorem and is particularly effective in text classification tasks like spam detection. Each of these algorithms has its strengths and is chosen based on the problem requirements. How to choose the right algorithm? Choosing the right machine algorithm depends on the type of problem being solved. For classification problems, algorithms like logistic regression, SVM, and random forest are commonly used, while regression problems use linear regression or decision trees. Clustering problems rely on algorithms like k-means and hierarchical clustering, and dimensionality reduction techniques include PCA and TSNE. For sequential decision making tasks, reinforcement learning algorithms like Q-learning are preferred. Additionally, factors such as data size, number of features, interpretability, and training time should be considered when selecting an algorithm to ensure optimal performance. Real-world applications. Machine learning has numerous real-world applications that impact our daily lives. Platforms like Netflix and Spotify use recommendation systems to suggest content based on user preferences. In finance, machine learning is used for fraud detection by identifying unusual transaction patterns. Email services use algorithms like Naive Bayes to filter spam messages. In healthcare, machine learning models assist in diagnosing diseases by analyzing medical images. Autonomous vehicles rely on reinforcement learning and computer vision to navigate road safety. While voice assistants like Siri and Alexa use natural language processing to understand and respond to user commands. Advantages of machine learning. Machine learning offers several advantages, making it a powerful tool in modern technology. It can identify complex patterns in large datasets that are difficult for humans to detect. It automates repetitive tasks, reducing human effort and minimizing errors. Machine learning systems are highly scalable and can handle vast amounts of data efficiently. Additionally, they continuously improve as they are exposed to more data and feedback. Their versatility allows them to be applied across various industries, including healthcare, finance, retail, and entertainment. Limitations and challenges. Despite its advantages, machine learning also has limitations and challenges. The performance of models heavily depends on the quality and quantity of data, making data collection and preparation critical. Overfitting is a common issue where the model performs well on training data but poorly on new data. Bias in training data can lead to unfair or discriminatory outcomes, raising ethical concerns. Many advanced models act as black boxes, making them difficult to interpret. Additionally, training complex models requires significant computational resources, which can be costly and energy intensive. Or algorithm comparison. Different machine learning algorithms vary in terms of speed, accuracy, and interpretability. For example, linear and logistic regression are fast and easy to interpret, but may not capture complex relationships. Decision trees are highly interpretable but can overfit. Random forest improves accuracy but reduces interpretability. Support vector machines are powerful for high dimensional data but can be slow. KNN is simple but computationally expensive for large datasets. Naive Bayes is fast and effective for text data, while K-means is efficient for clustering tasks. Understanding these trade-offs help in selecting the most suitable algorithm. Future of machine learning. The future of machine learning is rapidly evolving with new advancements. Automated machine learning or auto ML is making it easier for non-experts to build models. Explainable AI is gaining importance to ensure transparency and trust in decision making. Edge AI allows models to run on devices like smartphones, enabling real-time processing without relying on the cloud. Federated learning focuses on privacy by training models across decentralized data sources. Large foundation models like GPT and BERT are transforming how tasks are performed through transfer learning. Additionally, there is a growing emphasis on ethical AI and regulations to ensure responsible use. Now we come towards the conclusion. In conclusion, machine learning algorithms can be categorized into supervised, unsupervised, and reinforcement learning, each, each serving different purposes. Selecting the right algorithm depends on the problem type, data characteristics, and business requirements. There is no single best algorithm, and understanding their strength and limitations is essential. As the field continues to evolve, innovations like AutoML, explainable AI, and edge computing are shaping the future, making machine learning more accessible, efficient, and impactful. Thank you.